Hello, thank you for joining me. Today we're going to talk about balancing equations. And the reason we need to do this is because we learned about something called the law of conservation, which says that atoms can't be lost or gained during a chemical reaction. You can't end with a different number than you started with. So what we're going to do during this video is walk through how do we balance equations. And you can see here where it says for the following equation, you can read through those directions on your own when you're practicing on your own. I'm going to walk you through those steps. So let's see how we end up with the right number of atoms on both sides so that we can call the equation balanced. So right now we see that in this equation, it looks like I have 2 hydrogens and 2 hydrogens on the product side. Well, that seems okay. But then we've got 2 oxygens on the reactant side and only 1 on the product side. That is not okay in the chemistry world because it's kind of like, well, where did all that stuff come from? So what we're going to do is we're going to make this a balanced equation. So here's how we're going to start it. We're going to start by drawing a supply of the reactants. Well, one of my reactants is a hydrogen molecule. And when we do our supplies, we're just going to draw 5. That's kind of a good number to start with. Now that's kind of a made up number. So it's not like you automatically always have to do 5, but it's kind of a nice number to start with. And then we also need to draw a supply of oxygen molecules, which is 2 oxygens in each particle. They kind of look like little pig noses. And then when we do these equations, we're always going to have at least one of our product. So we're going to do HHO in the same particle. That's one of our products. Now, when we balance it, we can only make stuff on the product side if we cross it off on our supply, on the reactant side. So I made HHO, so I'm going to cross off H, H, and an O. Now, I'm not going to stop there because it's not balanced yet. Because I have what we call a broken particle. So that's a broken particle, meaning that there is something crossed off and something not crossed off. So then the rule says to get it to be balanced, we're going to make more of the products that will use up those broken particles. So we need to make something with an oxygen in it. Well, we only have one product. The product is just HHO. So when I do that, I will cross off that O in that broken particle and then 2 more H's. At that point, I don't have any broken particles, so then this tells us we have a balanced equation, and we can kind of check our work. So what we see is, look, 1, 2, 3, 4 H's were crossed off, and 1, 2, 3, 4 H's are on our product side. Then we can check to see, okay, I've got 2 oxygens crossed off and 1, 2 oxygens on my product side. So this is a way to check your work and see that the stuff we started with matches the stuff that we end with. It looks different and that's okay, but we have a balanced equation. So now we go back to our reactant side to fill in the blanks of our balanced equation and we count how many total particles did we use. Not how many individual atoms, but how many particles. I used 1 whole hydrogen molecule and another whole hydrogen molecule. So 1, 2. So you put a 2 in that spot. I used 1 oxygen molecule, so I put a 1 there. And I made 1, 2 water molecules, so I put a 2 there. So now this is our balanced equation, and then we diagrammed it to kind of prove and show our work. We don't have to do anything with those extra supply pieces. We didn't use them. They would just kind of float away like they didn't exist. All right, the other part of this that I want you to review is I want you to see from the beginning to the end, did the particles separate, meaning they pulled apart, combine, they came together, or they just rearranged? So you start with a couple things or more and end up with a couple things in a different order. So in this one, we can say that we have 2 separate reactants and 1 product, so we're going to say that they combined. That's the idea. Okay, let's practice this a little bit more. Let's do another one. So we're going to start it the same way by starting to make a supply of our reactants. Well, this reactant is a molecule that has 4 P's. That's what the P4 means. But they're all in the same particle. That's what, because it's a little 4, we know that it's all the same molecule together. Just drawing my supply. 1, 2, 3, 4. And then I need a supply of those little pig noses again. 1, 2, 3, 4, 5. That'll work. And then on my product side, I always have to have at least 1 product. Well, this product is made of 2 P's and then 1, 2, 3, 4, 5 oxygens. That's what that P2O5 says. But you can only make a product if you cross off your reactant pieces. So I cross off 1, 2 phosphoruses, P, and then 5 O's. 1, 2, 3, 4, 5. All right, but I can't stop there because I have a broken particle. Again, a broken particle is when something is crossed off, but other things are not. So I have to use up those broken particles. So I have to use something with an O in it. Well, I only have 1 product. So that means that I'm going to make PP again, O, 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 O. So 1, 2 phosphorus and 5 oxygens, which means again I have to cross off 5 O's and 2 P's. Well, I'm going to use up this broken particle that I had first, and then I'll also use up my oxygen broken particle. 1, 2, 3, 4, 5. At this point, I don't have any more broken particles. So that means that I can balance my equation. So I used one P4 molecule. I used 1, 2, 3, 4, 5 oxygen molecules, and I made 1, 2 product molecules. So then that would be my balanced equation because I have the same number of things crossed off that I made on the product side. So then now I compare the beginning to the end, and again it looks like my molecules from the beginning to the end combined. So I end up putting a C in the box. Okay, hopefully you're kind of getting the idea, but let's keep going. Let's do one more together. So this time when I draw my supply, I'm only starting with one reactant, but I still draw my supply of it. So NaOH, NaOH, NaOH. This is just my supply. And remember, the 5 that we draw is just kind of random. But then, to balance this equation, I need to make at least one of each product because that's the chemical reaction that happened. So 1A, and then I cross that off. I make at least one oxygen molecule, and then I have to cross off 1, 2 oxygen. I make at least one water molecule, and I have to cross off 2 H's and 1 O. Now, I notice that I've got some broken particles here that have Na in them. So what I could do is I could draw my 2 more NAs, that'll cross that off, and another Na, that'll cross that off. Now I still have this broken particle that has a hydrogen in it, so I can't stop making anything with hydrogen in it. But right now I don't have to make any more Nas or Os. So let's make another water molecule because that has hydrogen in it. But then I have to cross off 2 H's and an O, but then I still have that Na, so I have to make another Na, and then I cross it off. At this point, I notice that there is no more broken particles on my reactant side, so I'm ready to balance it. Or to double check my work, too. So let's go ahead and try that. So I have 1, 2, 3, 4 NAs crossed off, and I made 1, 2, 3, 4 on my product side. Okay, so that looks good. I've got 1, 2, 3, 4 oxygens crossed off. 1, 2, 3, 4 oxygens on my product side. So that makes sense. And then my last one, I've got 1, 2, 3, 4 hydrogens that I crossed off, and 1, 2, 3, 4 hydrogens on my product side. So because they are the same on both sides, we're going to say that that's balanced, and I'm ready to fill in my blanks. So I started this time with 1, 2, 3, 4 reactants that I used. I made 1, 2, 3, 4 sodiums. I made 1 oxygen molecule, and I made 2 water molecules. So then that would be a balanced equation. So the next thing I do is I again fill in that box. So from the beginning to the end, I look at my particles, and this time it looks like I started with one reactant that's split apart. So we're going to call that separate. All right, so hopefully that one, okay, you're starting to catch on. You feel like you know what's going on. All right, well, let's just do one more, I promise. Just one more together. And then you can start practicing on your own. So let's do this one. We're going to start it the same way we do all of them. This is aluminum, that one of my reactants. So I'm going to draw a supply of aluminum, Al. Plus, I have a chlorine molecule, which is a Cl and a Cl. So that's not a C and an I2. It's a lowercase l. And if you can't tell, you can always just check with your teacher, and they'll help you out. So 2 chlorines in that's my supply. My arrows then for my product says I've got to make at least one product. So I make my Al and then 3 chlorines. That's one product. But I can only make product if I cross it out from the reactant side. So 1, 2, we just need 1 aluminum at a time. 1 aluminum crossed off, and then 1, 2, 3 chlorines crossed off. But I can't stop there because look, I've got that broken particle. And so since I have a broken particle, I have to make another product. So I have 1 aluminum and then chlorine, 2, 3 chlorines. But then I have to cross off my pieces. So 1, 2, 3 chlorines and 1 more aluminum. I look at my supply, I don't have any broken pieces or broken particles, so I'm ready to balance my equation. I have 1, 2 aluminums that I used, 1, 2, 3 chlorine molecules that I used, and then I made 1, 2 products. And now I have a balanced equation, the same number of atoms that I started with, the same number of atoms that I ended with, so I don't break the law of conservation, because no one wants to break the law, that's scary. Okay, so then one more time, I take a look, what happened to my particles from the beginning to the end? Well, this time I start with two things and I end up with one particle, one thing, and so then that ends up combining. Okay, so at this point, if you were just watching this video for practice, you can go ahead and stop the video. If you were doing this practice, watching this video from Ms. Killinan, now you're going to go on and do these 8 example problems. You're going to start by always drawing a supply of your reactants, so 5 of each, whatever you start with, and then always make at least one product. But remember, you can only make things on the product side if you cross them off on the reactant side. So always start with 1. And then keep going until you have no more broken particles. Then after you have it balanced, then you're going to look at the beginning to the end and see, did the product all form from one thing? That means that the reactant separated. Did your reactants combine into one thing, meaning everything came together? Or did you just rearrange the pieces? They started with a few things, you ended up with a few different things in a different order. Okay? Have fun balancing equations.